Okay, so here's our second bonus video. This one's gonna have some more fractions, some more factoring. I did talk about, hey, we were gonna explain that splitting the numerator idea. So essentially, if you kind of think of, hey, what if I had 1/2 plus 3/2? Well, that gives us 4/2, right? And normally we would just simplify that to 2. But if we were kind of starting off with 4/2, instead of splitting it to 2, we could actually go backwards. We could say, hey, well, isn't that 1 plus 3 over 2? And we know, wait, that is 1/2 plus 3/2, right? That does work, right? Because that's what we started with. So we can split it, okay? But like I said, you can never split the denominator. So if you had 1 over, say like 2 plus 3, this does not equal 1/2 plus 1/3 because we don't add denominators, right? We need common denominators. So this does not work. So you can never ever split the denominator. So that's just something about math that when you get to higher levels, we kind of take advantage of that a lot. So with x's, especially if you take Calc 2 in college, you'll take advantage of that concept a bit. So that's something that if you ever notice, hey, I'm trying to simplify, but I have this positive sign in the numerator, you can always try that. So we're going to separate the top. So we're going to write this as tangent theta over tangent theta plus cotangent theta over tangent theta. So it's basically going backwards. Right now we have our like denominators, but we just split it. Tangent theta plus tangent theta is just 1. And cotangent theta over tangent theta, if you're really, really smart about this, you could kind of take the cotangent, make it 1 over tangent, and put it to the denominator. But I'm just going to kind of go the long way because that's a little more confusing for some of us. So I'm going to write cotangent was cosine theta over sine theta. And tangent theta is sine theta over cosine theta. And so now we'll kind of do our flipped reciprocal like we were doing before. And what I really, really want to make sure that we always do is that we always rewrite, I'm going to actually write this down here. We always rewrite this 1. Okay, that's another mistake I see people make all the time, is they have something really complicated and they focus on that. They're like, oh, the 1's no problem, I'll just remember it later, but they don't remember it. So always rewrite it even when you're doing the complicated stuff. So this is plus cosine theta over sine theta times its reciprocal, opposite reciprocal, cosine theta over sine theta, right? This becomes 1 plus cosine times cosine becomes cosine squared over sine squared, right? And when we have cosine over sine, that was cotangent. So this becomes 1 plus cotangent theta, but it's not cotangent, it's cotangent squared because of that squared. So that first one's a little tricky, but that's just kind of this new concept that we're going to be talking about, okay? If you need to finish copying this, I'm going to erase it. So just pause the video really quickly. I'm going to erase this. Okay. So next example, we have secant squared minus 1 over secant squared. We're going to just do that same thing. We're going to separate it first, and then we're going to go ahead and worry about how can we simplify it. So we can simplify this one, secant squared theta over secant squared theta minus 1 over secant squared theta. And secant squared divided by itself is just 1 minus, and then 1 over secant squared theta gives cosine squared theta. And then you can go back up to your table, right? Whenever you see that squared, you want to be thinking about those Pythagorean identities, and in that table you'll see that this is equal to sine squared theta. Next one's kind of fun. It's weird, but it'll be kind of interesting what it simplifies to. So like I said, I always try to leave my cosine and my sine if I can, and start simplifying the other guys. So what does tangent theta turn into? Tangent theta can be written as sine theta over cosine theta. What does cosecant theta simplify to? It goes to 1 over sine theta, and then we're just going to leave cosine theta alone. Okay. And now let's look at what can we cross cancel. So we can cancel out the sine thetas, put a 1 there, and we can cancel out the cosine thetas. So this all just turns into 1. And we'll notice that that can happen, that tends to happen in trig identities. It can be kind of frustrating or kind of funny. Like we have this big complicated thing and it just all becomes 1. And what that means is no matter what number, theta is like a variable, right? You could put, an angle in there, 30 degrees, 45 degrees, 70 degrees, or, in radians like pi over 2, pi over 6, pi over 4. No matter what we plug in, you're always going to end up with 1. So that's interesting. Okay. So these identities, I talked about these, right? We do not want to move. You're not going to move anything from one side to the other side. You're just going to kind of draw a line here, and you're going to try to make the left side look like the right side. Okay. So I like to just put equals 1, keep writing that. So sine theta, cotangent theta, secant theta. I'm going to do that same thing that we just did. I'm going to leave sine theta alone. Cotangent theta we're going to write as cosine over sine. And secant was 1 over cosine. So now what can we cross cancel? We can cross cancel cosine thetas, those become 1. Sine thetas, those become 1. So we get 1 equals 1, put a check mark, and we're done. So that's kind of how that goes. This next one, same thing, I'm going to write my line through the middle. Okay. 1 minus 2 sine squared theta. Whenever we see the squared, I was saying whenever we see the squared, we want to start thinking about our trig identities. So I'm going to put a parentheses where sine squared was. I'm going to plug in, looking at that trig identity, sine squared can be written as 1 minus cosine squared theta. I'm not going to scroll up. You can scroll up and look at the notes, but whenever you see sine squared theta, you can replace it, right? It was one of those identities. It was equal to 1 minus cosine squared. Okay. On the right side, we're just always rewriting what we had. Okay. Now let's distribute this. So we get 1 minus 2, and then plus, right? Because negative 2 times negative becomes positive 2 cosine squared theta equals 2 cosine squared theta minus 1. And 1 minus 2 is negative 1 plus 2 cosine squared theta equals 2 cosine squared theta minus 1. They don't look quite the same yet, but they're basically there. We can just flip those, right? That's if you have 1 plus 2, that's the same as 2 plus 1. I don't remember if that's associative or commutative. One of you guys can look it up if you really want to. I might give you some extra credit. But basically, we just flip these. 2 cosine squared theta minus 1 equals 2 cosine squared theta minus 1. Put a check. We're done. So kind of another concept that we have, right? This should be really easy for us to factor. If you had a squared minus a squared b, right, we can factor out an a squared from both terms, and we have 1 minus b left. We can do the same thing with trig. So when we have something with trig in it, if we're verifying an identity, right, I notice, hey, I have cosecant squared and cosecant squared in both. So I can factor out a cosecant squared theta because it's in both of these. And this is something we actually will do in calculus a little bit, is that factoring of trig terms. Okay. So in this case, I know that I said most of the time we're always going to want to leave cosine, leave sine, and replace the cosecant. But the exception to that is whenever we have those squareds, our first thought before we do that is before we do 1 over sine or sine over cosine, we always want to look at our identities, our Pythagorean identities, those sine squared plus cosine squared equals 1 and all that stuff. So we have this 1 minus cosine squared theta. Does that appear in our table? If we go back up and we look at our table, 1 minus cosine squared can be written as sine theta, sine squared theta. So we're going to replace that first. Now that we've replaced that, now we can go to the cosecant and write that as 1 over sine. But it's not 1 over sine, it's 1 over sine squared, because that's kind of how we have, because we have the squared. So now these cancel out. 1 equals 1. Put a check mark. All right. All right. This next one's a little bit tricky, and it goes to FOIL. Okay. If you don't know how to do FOIL, please, please, please go look it up. I really, really do not want you guys doing this box thing. It just takes way too long. Calculus is a timed test. If you're having to do this every single time you have to FOIL, You're going to be wasting like minutes, you know, like 5, 10, 15 minutes on your test because FOIL is so common in math. So please, if you need to, just go watch a YouTube video on how to do FOIL. But this kind of area method, whatever we call it, it's just going to take way too long for higher math. We need to move on to FOIL. Okay, so FOIL is first, outside, inside, last. So we multiply our first terms. Sine times sine is sine squared theta. Then outside, so plus sine theta times cosine theta. We just write it like that, sine theta, cosine theta. Then inside, there's a minus here, don't forget. So it's negative cosine theta times sine theta. And then last, cosine times cosine, but don't forget that negative. So negative cosine times positive cosine would be negative cosine squared theta. All right. Now we're going to try to add any like terms. At first glance, it doesn't look like there are any like terms, but actually these middle two terms are like terms. And the reason for that is we can rewrite sine cosine as cosine sine or vice versa, right? If you had x times y, that's actually the same thing as y times x. Those are equal, right? You can just flip them. It's like having 2 times 3 is the same as 3 times 2. There's no difference. So I'm going to go ahead and just kind of rewrite that. Sine squared theta plus sine theta cosine theta minus, I'm just going to move this one in front, write the sign in front, sine theta cosine theta minus cosine squared theta, right? These guys cancel out, and we're left with sine squared theta minus cosine squared theta. And to me, this is the answer I would expect the AP test to have. I would not simplify it any further. But, you know, if you're doing an identity, they might have you just want sines, or they might want you to just have cosines. So, you know, they might do something like, you know, cosine squared is 1 minus sine squared. And so that becomes sine squared theta minus 1 minus, or plus sine squared theta, right? Because this negative distributes. And so now we get 2 sine squared theta minus 1. That might be an answer. They also might, on a trig identity, like on ones that are verifying, right? Those ones where they're saying like basically get to this answer on the right side. They might want you to just have cosine thetas. So you might need to replace the sine theta. But to me, what I boxed, you know, this is, we're pretty much done, right? You can't cancel anything else out. So I think we're good. Okay. And then I also want to just show us one where we're foiling again, but this time with FOIL, whenever you have squared, you still want to do FOIL, but you just need to rewrite it. Now, if you learn the shortcut, I like the shortcut even better. But just please make sure that you don't just put tangent squared theta plus 1 squared. Like that is totally wrong. You can't just square both of them. It does FOIL out. Now, the shortcut is that you square the first, you square the second, and then you multiply them and multiply by 2. If you know that shortcut, great. If not, just FOIL it out until you learn it or forever, okay? So first, tangent times tangent is tangent squared theta plus outside, tangent theta times 1 is tangent theta, plus inside, plus last. Okay. Now we're going to add any like terms. Tangent theta. We get tangent squared theta plus 2 tangent theta plus 1. Technically, this can be factored more. I'm not going to worry about that. So I'm going to just leave our answer right there. I think that's fine. Okay. So on our homework, I got rid of a couple of these just because they have some weird factoring stuff. But on our homework, we're going to do 1, 3, and 4, where we simplify them. I posted the answers for those. Okay. And we're going to do 5, 6, 7, and 8. I did not post the answers here. You're going to have to kind of simplify it to get the left side to look like the right side. I am going to give you guys a hint on number 7. Number 7 is extremely challenging. So I kind of am starting you off, okay? What you're going to want to do is, and the reason I'm starting you off is I said in the last video, you always want to leave the denominator alone and simplify the numerator. That's whenever we're simplifying. But this is not simplifying so much as it's like a puzzle of how do we get the left side to look like the right side. So in this case, the best way to do that is actually to FOIL out the denominator. And the reason I want to FOIL out the denominator is I'm trying to get my left side to look like my right side. Well, if we look at my left side, I see this 1 minus cosine theta in the numerator, and on the right side, it's in the numerator. So we actually don't want to do anything to change it. It's already good. That's what I want. So what we need to do is we need to get rid of everything else and make it look like basically getting rid of anything else in the numerator and making the denominator become sine theta. So what we're going to do is we're going to FOIL out the denominator, right? We're going to do first outside, inside, last on the denominator. And that should start simplifying, and you should be able to cancel out a sine theta, and you'll be left with only one sine theta in the denominator. So that's kind of a really challenging problem. Do your best on it. Let me know in office hours if you need help. All right, thanks, guys.